Uh, Today's webinar is on electrospray ionization mass spectroscopy, its instrumentation and applications. And today's speaker is Dr. Pranav Kumar, and we have a chief guest with us, Dr. Ganeshan. Welcome you, sir. Our Honorable President, Dr. Chandrachudan, sir. Vice President, Dr. Raghav Sharan. Chairman, Webinar Committee, Rajiv Raghavan. Honorable Dr. Nair, Balram sir, other dignitaries on this platform, and dear participants. I welcome you all in this webinar. Thank you. Over to you, Shreya.
Thank you, sir. Prayer is the most powerful tool mankind has. The function of prayer is not to influence God but to influence the one who is praying. So let's seek some strength and wisdom from God and move towards our traditional and auspicious lamp lighting ceremony. I would request all the dignitaries to virtually light the lamp. Is my screen visible?
Yes, it is visible.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीम् अभयदां जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
Now, I request Dr. Raghav Saran, Vice President ISAS National, to give opening remark.
Honorable President Dr. Chanchudan, Professor Ganeshan, Honorable Chief Guest Dr. Pranav Kumar, Eminent Speaker Dr. Rajiv, Chairman of the Webinar Committee, Dr. Nair, Dr. Adya, Dr. Bharati, Chairman of Nagpur Chapter, distinguished luminaries, EC members, ISS, friends, and participants. Good evening to you all, and welcome to our Scientific Knowledge Enrichment Program. As we all know, the program was inaugurated on 4th July 2020 in view of the compelled social distancing due to pandemic. In morning in Nagpur, it commenced with 4 talks on post-COVID management by eminent personalities in their respective field. And in evening, it was inaugurated by headquarters on emerging technologies and methodologies in analytical sciences. The program comprised of talks by scientists, technologists with expertise par excellence in their respective fields. on varied topics, starting from analytical chemistry in space, nanosensors, and electrical techniques for COVID-19, e-waste recyclation, nuclear medicine in cancer, nuclear biotechnology in agriculture, nuclear power for clean green energy, XRF, total XRF, natural immunity and vaccine in contagious diseases, graphene and derivatives, recovery of valuable metals from spent lithium battery, and many, many more. Radiopharmaceutical, high power neodymium glass laser, lithium ion battery for electrical vehicles, MIP, microwave induced plasma electrical technique, and all as per the objective of the society of disseminating multidisciplinary science. And friends, we are occupied till 17th of July. On 3rd of July, Executive Committee is going to complete another year of its tenure, and it is being celebrated by a lifetime opportunity talk with a personality whose glitter in science domain is unparalleled. Dr. Anil Kapoorkar, former Atomic Energy Commission chairman. We all must join on the day to quench our scientific quest and derive benefit from the one of the rarest crop. So let's keep the date reserved in our calendar. We are privileged today to have Professor Ganeshan as chief guest, a leading scientist in diagnosis and therapy of cancer, having academic collaboration with centers, cancer center, cellular imaging, etc. in USA, New York, San Francisco, Australia, Japan, etc. He founded and medical physics, and he is obviously professor and head of medical physics and director health center, Anna University. We welcome you, sir. Today's talk by Dr. Pranav Kumar on electron spray ionization in mass spectrometry is of immense importance by an expert in the field, an IIT Chennai product, recipient of ISMS Younger Mass Spectroscopist Award for his contribution in the field of ESI-MS. Thank you. What do you share?
Thank you, sir. Before we move ahead, I request everyone present here to mute themselves until required for efficient audio quality. Now I request Dr. Rajiv Raghavan, Chairman Webinar Committee ISAS, to address the august gathering.
Thank you. Respected Dr. P.P. Chandrachudan, President ISAS, Professor Dr. S. Ganeshan, Anna University, the chief guest today, and Dr. Pranav Kumar, Fuel Chemistry Division, BRC, our distinguished speaker today, Dr. Avinash Bharati, Chairman, ISAS Nagpur Chapter, Dr. Raghavcharan, Vice President, ISAS, Dr. Nair Sir, Balram Sir, other distinguished audience, ISAS member and friends. A very good evening. Today we have an eminent scientist, Dr. Ganeshan, as the chief guest. We are very happy to have Dr. Ganeshan as the chief guest, an expert in the field of medical physics. And also today we have a true analytical talk by Dr. Pranav Kumar on the electron ionization method for mass spectroscopy. And you all know that in mass spectrometry, ionization plays an important role in the analysis of different materials, where electron spray ionization is considered as the best ionization technique and used especially for the identification and quantification of organic compounds. A lot of literature and library is available mainly on electron spray ionization based mass spectrometric data only. And we are expecting uh, our very talk from our speaker today. Thank you.
Thank you, sir. Now I would request our Honorable National President of ISAS, Dr. Chandrachudan sir, to address us.
Thank you, Dr. Sreya. Good evening to everybody. My dear Professor S. Ganeshan, today's chief guest, Dr. Pranav Kumar, today's theme speaker, Dr. V.R. Nair, Dr. Raghav Sharan, Dr. Rajiv Raghavan, Dr. Avinash Bharati, Dr. Manjanna, and Dr. Balram, Chairman of all ISIS chapters and ISIS EC members of headquarters and chapters, distinguished invitees, and eminent participants. First of all, I would like to give a very warm greeting from the ISIS headquarters to all of you. Friends, for ISIS, it is a great day today, primarily because Professor S. Ganeshan, I would like to classify him as the father of medical physics education in the university system in India. It's a high demand sector, and his contribution towards this manpower development is very unique. Professor Ganeshan is an internationally acknowledged Indian academician and outstanding high impact research project leader focusing on laser photodynamic therapy, cancer therapy, etc., playing a leading role in the country. His active research projects in association with none other than Dr. D.D. Bhavalkar, father of Indian laser program, have been always highly productive and very highly appreciated. Professor Ganeshan established the medical physics department in the Anna University, Chennai for the first time, and many other universities followed this example. He has played a key role in multidisciplinary educational system in Tamil Nadu, playing the key role as the registrar of Anna University, governing a host of large number of institutions spread over Tamil Nadu, establishing an exemplary working model for the entire India. Thank you, Dr. Ganeshan, for sparing your valuable time and being with us as our chief guest today. Friends, we have Dr. Pranav Kumar, who is the alumnus of the prestigious internationally acknowledged training school of BARC, currently working as a senior scientist of BARC and the postgraduate professor at the Homi Bhabha National Institute, Mumbai, which is a prestigious deemed university under the Department of Atomic Energy. Dr. Pranav Kumar is specialized in mass spectrometry with a special focus on ESI mass spectrometry. With his, in recognition of his very credible research work using ESI-MS, Dr. Pranav Kumar has received prestigious awards for his active contribution as an expert in this field, in this specialization. I sincerely look forward to listen to him with great interest. On this occasion, I would like to also thank Dr. Rajiv Raghavan, Dr. Raghav Sharan, and Professor Avinash Bharati, Dr. Jayalakshmi Adia, and the ISIS webinar team of both the headquarters and the Nagpur chapter for organizing very useful webinars on the ISIS platform. I convey my best wishes to all of you. And with this remark, I hand over the mic to Dr. Shreya. Thank you very much.
Thank you, sir. Now, I invite Dr. Seema Rawat, Associate Professor, Priyadarshan, College of Engineering, Nagpur. To introduce our chief guest for the evening, Dr. S. Ganeshan, Professor, Department of Medical Physics and Director, Health Center, Anna University.
Thank you, Shreya. Respected dignitaries present online, good evening to all of you. I, Dr. Seema Rawat, Assistant Professor at Priyadashini College of Engineering, here to introduce Dr. S. Ganeshan, a very eminent and dedicated personality in the field of biophysics. Dr. S. Ganeshan, PhD, MRSO, FASC. He is a professor at Department of Medical Physics and Director at Health Center, Anna University. His research and development contribution includes 2 patents, 27 research students, publications at reputed journals. The publications are around 225. 120 publications are published in national and international conferences. All the publications are at very good number of citation and H index. His collaboration with international academics includes City University of New York, USA, Memorial Sloan Kettering Center, Cancer Center, NY, USA, Center of Cellular Imaging, USA, University of California, Queensland University, Australia, and so on. His administrative responsibility include he handled many administrative portfolios such as Director, Health Center Registrar, Founder HOD, Department of Medical Physics, Chairman at Anna James Science Park School, Director, Center for Students Affairs, Secretary, Anna James Science School Park. He also contributed a lot for the development of infrastructure at Anna University, which includes the accommodations at UG and PG levels for students, including girls and boys, UG classrooms, labs, seminar halls, conference hall, constructions including different types of walls, and dedicated health center buildings at MIT campus. He is also honored by many awards and certificates of appreciation, which includes Best Thesis Award, Best Paper Award, Fellow for Academic of Science, Tavas Award, and recently he is awarded with a Lifetime Achievement Award by Indian Spectrophysics Association 2020. His contribution to university includes University with Potential for Excellence, NAC with CGPA of 3.46 on a 4-point scale at A grade. He also introduced choice-based credit system from 2016-17. He also introduced the online applications for different admissions from the session to 2016-17. Also includes MOU signed for academics as well as MOU signs with the international bodies. He also introduced the e-governance. All in all, we can say the technical background is introduced by him in the Anna University when he was the registrar of that same university. So all in all, we can say the today's chief guest, Dr. S. Ganeshan, is a gem personality. So on behalf of organizing team, I welcome you, sir. Thank you, sir. Over to you, Shreya.
Thank you, ma'am. Now I request our chief guest, Dr. S. Ganeshan, to say a few words and inaugurate today's webinar.
Thank you, Dr. Seema, for your nice introduction. Good evening to one and all. The most respected president of Indian Society for Analytical Scientists, Dr. P.P. Chandrasudan, scientist from BRC, well-known program coordinator all over India from BRNS. In particular, my mentor and my godfather for all my research career, whatever I have done something, all because of his support, guidance, and timely help. I respected Roshan Saran, the National Vice President of ISAS, Dr. Rajiv Raghavan, Chairman, Webinar Committee, ISAS, Dr. Avinash Bharati, Chairman, Nagpur Chapter, ISAS. Today's eminent speaker, the national scientist, Dr. Pranav Kumar, scientist of Fuel Chemistry Division, Baba Atomic Research Center, Dr. Balram, the dynamic man who has been associated wherever this ISAS is going on, Dr. Nair, Dr. Balram, Dr. Vijayalakshmi, the joint conveners, Dr. C.P. Pondur-Nekar, Dr. Kanangu, Dr. Shinde, Dr. Indrani Das Sharma, organizing committee members S.K. Singh, Dr. Ubedra Singh, Dr. Pranav Nagar Naik, Dr. Vaishali, Dr. Kavita Kaur, Dr. Seema Raut, and the compare stay up, other eminent scientists, most respected professors, industrialists, the office bearers of ISAS at national level as well as at Nagpur chapter. Good morning to one and all. I am indeed very happy to be here and also honored to participate today's national webinar course on Electrospray ionization mass spectroscopy, its instrumentation and applications, delivered by the eminent scientist Dr. Pranav Kumar, organized by Indian Society for Analytical Scientists Nagpur chapter. And I'm very happy to note that ISAS was established in the year 1983, and from the year of establishment, it has been serving the nation, and in particular to the scientists who are involved in the field of analytical science and technology, by the way of conducting more than 38 national and international conferences, having 3,000 eminent scientists, industrialists, technologists, and I'm excited to note that even during this pandemic period, for the last 1 year, ISAS has organized more than 50 webinar programs and making ISAS very active and not allowing the scientists in the field of analytical science and making them to as vibrant scientists to analyze all their output during this pandemic period. So I really appreciate the able contributions, dedication by all the office bearers, and in particular the president, secretary, vice president, and others who have been involved in organizing this webinar program. And With regard to today's program, I would like to inform that knowingly or unknowingly, starting from the founder office bearers and the president and vice president and other office bearers, actually engaging the activities of ISAS, because no field I can say without analytical instrumentation, without analysis. So all fields of science and technology needs analytical instruments. So with regard to this today's program, I would like to inform that the field of analytical science and technology has not only emerged in or engaged at college levels and laboratories, but utilized by all areas. I can say in all multidisciplinary areas like health science, agriculture, environmental monitoring, forensic sciences, biotechnology, pharmacology, chemical sciences, physical sciences, security, safety and security, as well as industries. So although many advancement has come because of the development of electronics industry and because of the development of various detectors technology and because of the availability of the various softwares to analyze the results, I would like to inform that many young minds giving the sample and taking the output without knowing what is happening in between. So just they are taking the printout of the results and keeping and showing the results. So it is a need of our, though advancement has come, the software is giving the results, but we got to inculcate the young minds. What is the basis behind all the analytical instruments, how it functions, how it gives the output, and in what are the way one can interpret the results, all those things. I think by considering these things only, ISAS has organized this program, has been organizing various programs actually. And coming to today's talk, actually, this electrospray ionization mass spectroscopy. Unlike other spectroscopic techniques, I say I'm working on optical spectroscopy in cancer diagnostics using fluorescence, Raman, diffuse reflex spectroscopy. Comparing the analysis of other optical spectroscopy techniques, but this mass spectrometry technique is needs expertise actually. The analysis results, one cannot just like that analyze without knowing the fundamental concept and what is the nature of the output without training the people. So rightly, ISAS Nagpur chapter, he has selected this topic. Not only he has selected this topic, and also an eminent personality who has been working in this field and published many reputed published many papers in reputed journals actually. Although I am a laser man, I used to teach to the students. Laser has three parts actually, main components: an active medium, a resonator, optical resonator, and a pumping system. It has electron spray, ionic spray, and sample system and detector system. But the output side, it is highly complicated one. How to get the output, how to see where he speaks. Although it gives very good results and detects molecules, proteins, and impurities at femtomole level for even 1 microliter of the sample volume. That is the advantage, because nowadays, as a biologist, biomedical fellow, sample is very, very, very minimal. With this minimal sample, how to get more results. So this ESIMS will give results or identify trace quantities at femtolable level, even in 1 microliter level. So such wonderful instruments can be utilized effectively only if he knows his principle and functioning and how to analyze the results. So in this context, I thank the organizer for having selected this wonderful topic and also wonderful speaker. I, on behalf of ISAS National Level National Organization, as well as Indian Society for Analytical Scientists Nagpur chapter, thank the speaker for having accepted to deliver this talk for the benefit of the existing scientists as well as the future scientists. I would like to request the webinar organizers and also President Dr. Chandrachudan, if not so far we have conducted around more than 50 webinar courses. This may be put it in your web portal so that the young minds, whenever they want, they can see those talks. Actually, they can learn. Those who are not participated are in future. So that is my request actually. And in the last lecture also, I think Raman Spectroscopy and its applications. So all the 50 invited talks will be made available in the web portal of Indian Society for Analytical Scientists. With this, I once again thank the organizer for having allowed me to participate and interacting with the scientists, eminent scientists. With this, I thank once again one and all. Thank you. Thank you. Jai Hind.
Thank you, sir. We are honored to have you as the chief guest for today's webinar. Now, I request Dr. Vaishali Meshram, Associate Professor, Dharampet Science College, Nagpur, to introduce our guest speaker for the evening.
Thank you, Shreya. A very good evening to one and all. First of all, I would like to thank Dr. Avinash Bharati sir, Professor and Head, Department of Applied Chemistry, Ramdeobaba College of Engineering, Nagpur, and Chairman of Indian Society of Analytical Scientists, Nagpur chapter, and convener of today's webinar for giving me opportunity to introduce today's guest speaker in this virtual platform. All respected dignitaries and my dear friends, we are privileged to have with us as guest speaker Dr. Pranav Kumar, Senior Scientific Officer, Fuel Chemistry Division, Bhabha Atomic Research Center, Mumbai, and visiting faculty for PG at Homi Bhabha National Institute, Mumbai. It is a moment of rare pleasure to introduce today's distinguished guest speaker, Dr. Pranav Kumar. He obtained his MSc degree in chemistry from Indian Institute of Technology, Madras. After graduating from 49th batch of training school, BARC, he joined mass spectrometry section of Fuel Chemistry Division, BARC, in the year 2006. He obtained a PhD degree from Homi Bhabha National Institute, Mumbai, in the year 2014. Dr. Pranav Kumar sir is well known for his significant scientific contribution in the area of mass spectrometry and liquid phase separation techniques. He is a recipient of ASMAS Young Mass Spectrometrist Award for his contribution in the field of application of electrospray, ionization, mass spectrometer for studying metal ligand equilibrium for the actinides and the lanthanides. His contribution towards academic excellence has been highly significant, which has been proved by his publications. He has published more than 60 research papers in national and international journals of repute. Being so knowledgeable and outstanding in the field of mass spectrometry, Dr. Pranav Kumar sir is always called as guest speaker at various Indian institutions and abroad. With this brief introduction, once again, on behalf of organizing team of webinar, we welcome you, sir. Thank you so much. Now over to Shreya.
Thank you, ma'am. You have done justice in introducing our guest speaker. I know all are eagerly waiting to hear from our guest speaker, Dr. Pranav Kumar. But before we begin, I would like the dignitaries and the participants to note that during the talk, if you have any questions, please post them in the chat box so that Dr. Pranav Kumar can answer those questions in the question and answer space after his talk. So, with that being said, I now invite our guest speaker, Dr. Pranav Kumar, to deliver his talk.
Thank you and good evening to one and all. So first of all, I would like to thank the organizer for giving me opportunity to present today the work on the electrospray ionization mass spectrometry. Especially I would like to thank the Chandrachuran sir, Saran sir and Adya madam for giving me this opportunity. So I will be presenting the work. Is that visible?
Yes, sir. It is now. It is visible now.
Is it visible?
Yes, yes, it is visible.
Yes. Okay, so is it visible to everyone?
Yes, yes, sir. Very much.
So the topic is electrospray ionization mass spectrometry, and today we will be discussing about the basic principle of that and also application part. The name was given, the electrospray mass spectrometry is nothing but making elephant molecule fly, and that also we will see why this is given the name. So the outlay of my presentation is, we will have the brief introduction about the different milestones achieved in the mass spectrometric development. So basically history about the mass spectrometer and also ESIMS development. Then introduction of the ESIMS process and followed by the application in the different field. So basically the three parts. First one is the history, second one about the mystery about the ESIMS, and the last one is about chemistry about the ESIMS. So as analytical chemist, I would like to start the very basic concept that what is the analytical chemistry. It has the two branches broadly. One deals with the instrumental part, another is about the chemical method. Now, instrumental part consists of the different analytical techniques, which has the classification based on the spectroscopy, and another is spectrometry, and that we will see that why the name spectrometry is given. Spectroscopy basically deals with the electromagnetic radiation interaction of the light with the matter, whereas spectrometry deals with the studies of the ions. And also chemical method consists of the same very known titration method, solution chemistry. So if you see the mass spectrometry, it is nothing but a measurement device which can measure the molecular or atomic weight of the sample by measuring the mass to charge ratio of the ions. So it has a three-dimensional application. The first one, it can be used for identification of the substances, then also quantification of the substance, that how much is present, and also it used as a fingerprinting, that isotopic composition can be correlated with the origin of the element. So the as analytical figure of merits, if we see, it also said, yes, any problem? So as we see the analytical figure of merits, it satisfied the different analytical figures of merit like selectivity, specificity, sensitivity, and precision accuracy also. So if you see that what is the name we should call, whether spectroscopy or spectrometry. So the how it has changed basically. Initially it was used as the mass spectroscopy, but later on it was known as mass spectrograph because the separated mass were analyzed by using photographic plate. So that time the name was given spectrograph. But now the name is spectrometer because now the information of the separated masses is recorded electronically. And so if you see the broad classification, as I told, that the person or the instrument which deals with the ions is known as spectrometers, whereas the instrument or person who deals with the light is called spectroscopy, sorry. So this is the basic diagram of the mass spectrometer, which consists of the three parts: the ion source, ion separator, and detector. Of course, depending upon type of ion source, you require the vacuum of ion source also, because there are two classes of ion source. One is atmospheric ionization source, which can work at the atmospheric pressure condition, whereas the other ionization source requires high vacuum also. So this is the name of ion sources keeps on increasing. Now different ion sources has been included, but I would like to take you all the how historical development has taken place of the mass spectrometer. So the father of this spectrometer, mass spectroscopy or spectroscopy that time, but now spectrometry, the present condition, is that J.J. Thomson, who has developed the positive ray theory experiment and awarded the Nobel Prize in 1906 in the physics. Later on, his students, the Einstein, who used again the mass spectrometer for successfully elucidating the existence of the isotopes, where he has demonstrated the neon isotope study and also calculated the atomic weight of the neon. Then this is another milestone in the mass spectrometry. The person is he is the Alfred Neil. And why this is a milestone? Because this person has developed the sector field instrument. And Professor Balaram is there, who has used basically the sector field instrument. He will be convinced that this is the still till today offering the best resolution. But if you see the history, it was very interesting part. He was electrical engineer that time. But around 1935 or 1930, since there was not much higher study scope of electric engineers, so he switched over to physics. And advantage he got that he has basic knowledge of this physics and designing knowledge of the as an electrical engineer. So he designed the magnetic sector instrument, and later on, the Johnson and Neil both developed the double focusing instrument, which is used in if you go for high resolution ICP-MS. That is the one of the best instrument as of today. Not only that, he isolated the uranium-235 also. Now, this was his scientific achievement. Another achievement was that he was a very generous person. That means he was promoting the development of the instrument, and also the person who used to contact, he was giving the advices also. So it is said that he was giving idea and instrument both together to the interested person. Now, but if you see the 1940, the instrument, mostly mass spectrometer, as a chemist was used for the analysis purpose only. And therefore the Gresham said that the hardcore chemist at that time used to think mass spectrometer as a black magic tool only. However, MS grows organically in the year after 1950, and the credit goes to three chemists from the US and well known now McLafferty, Weinman, and Jeracy. Because McLafferty rearrangement is the well-known nowadays. So from there, the chemist started using mass spectrometer, and now it switched over physics domain to the chemistry domain. An interesting milestone was in 1956 when the coupling of gas chromatography, one of the that time very known separation technique, was coupled with the mass spectrometer. However, still those days there was not much technique or not any technique which can ionize or detect the ions directly from solution to the gas phase. That means it was still one has to convert the species into the gaseous form, and then only it can be detected. But that concept of electrospray goes to the Michael Dole, who is known as the brainchild of the Malcolm Dole, because at that time 1965 around, he was looking for a technique which can analyze or determine the molecular mass of the synthetic polymers without any fragmentation. But he happens to visit on the automobile shop where he saw the electrospray process is used for the painting process, where charge droplets is attracted towards the metal surface of the automobile bodies. Then the same concept he utilized for the development of the instrument for the analysis of the polystyrene molecules in the mass spectrometer. And this is his device where he designed the technique where the ions from the solution can be converted into the gaseous form and can be determined. But the problem was that his mass spectra consist of the many solvent molecules, and therefore it was very difficult to find out which peak consists of which species. As Ganesan sir rightly said, that the only spectrum will not give any information. Therefore, he could able to successfully develop the spectrum, but analysis was the difficult part. Now, 1960 to 98, there was no much development in this regard. However, 1980, the Professor Lipinski and Howard from the Yale University Medical School, they were trying to analyze the biopolymers without any much fragmentation. So he happens to see the report of the Malcolm Dole, and interestingly, he mentioned in his report, the reference was given about the John Finn. That time John Finn was working on the ion beam. He was expert in the nozzle and skimmer kind of techniques. So he has used the John Finn instrumentation application in his application or his development of the electrospray ionization source. So that time he was also in the Yale University. So both the professor approached him for the development of electrospray ionization source. However, John Finn was approaching at the 65 age. So he was at the verge of retirement. However, he took this challenge and demonstrated the ability of electrospray ionization to produce the positive and negative charge ion. Now, what he did differently from the Malcolm Dole was something interesting. Now, Malcolm Dole used the direct electrospray ionization source, and so the spectrum he got was all basically the solvent molecules. So spectrum was filled with the background noise. And therefore, here with this experiment, the Finn used a curtain gas to remove the solvent from the analyte of interest. And also initially he used a small molecules because whatever the mass analyzer was used by the Malcolm Dole was not capable to analyze the higher molecular masses. And that was another drawback in the Malcolm Dole design. However, the John Finn was very much grateful for Malcolm Dole throughout his career for demonstrating the ability of electrospray source for production of the ions. And therefore, in his lecture, he gave the name flying elephant, because here the higher molecular mass like proteins can directly convert it from liquid phase to the gas phase, and therefore this technique is also known as flying element. Now here again interesting thing is that when 1985 he was making presentation, John Fenn, in a symposium, and therefore everybody was applauding and appreciating his effort. However, he saw in that symposium Malcolm Dole. So he requested all the audience to acknowledge or give the credit to the Malcolm Dole. And he also requested Malcolm Dole to stand, and everybody was given standing applause for the Malcolm Dole. And that was moved him, Malcolm Dole, so much that that was the first and last face-to-face meeting between these two eminent scientists. However, they continue the good relationship in future through the later exchange. Another interesting thing was that when John Fenn was developing different analytical techniques and analyzing the different samples, he used to give the reference to the Malcolm Dole work. So one time, Malcolm Dole requested to send the printing paper of the manuscript, because as you know, those times there was no online material, there was no online resources available. So one has to get the hard copy, printed copy only. So the John Fenn gratefully he sent the printed version of the manuscript. Somehow or other, after 3 months, Malcolm Dole again wrote to the John Fenn with apologetic manner that somehow he lost the manuscript which was sent by John Fenn. And with the letter, he also sent $20 that time, so that he can again reprint those paper and send it back to the Malcolm Dole. And that was again something heart-touching for John Fenn. He not only returned that, but throughout the career, he was also very much interested that how much Malcolm Dole can get recognition. So this was the year 2002. However, Malcolm Dole was left this world in around 91 and 92, could not see the full flourishing of the ESIM source, which faced the Nobel Prize for John Fenn in the year 2002. Another person from again mass spectrometrist, he was known for the development of the Marley source, which is again another very useful technique nowadays. So if you see the mass spectrometer development, now the development consists of the two places, the ion source, which are all having the different name like inductively coupled plasma, thermal ionization, Electrospray, metric assisted laser disruption ionization source. So these are the classification based on the ion source also, like ICP-MS, TIMS, ESIMS. However, the classification is also based on the mass analyzer, and those analyzers are like quadrupole, time of flight, magnetic sector, and also the ion source are classified based on the soft and hard ionization source. The soft ionization source is one that retains the information of solution phase. That means fragmentation process is negligible or very less. Whereas hard ionization source are that which allow the element to undergo fragmentation, and there you can do the element. Now, very ironically, the person who deals with the soft ionization techniques wants that his molecule should not undergo fragment, whereas the person or analytical chemist who deals with the hard ionization source wants that his element should not undergo the formation of molecular ion. That means he wants the element in its elemental form. Therefore, this different kind of requirement has catered the development of the mass spectrometer throughout the time. And therefore, mass spectrometer also can be classified in two different categories. One is called inorganic mass spectrometer, where you require the isotopic ratio measurement, TIMS, or elemental analysis like ICP-MS. Those kind of mass spectrometers are inorganic mass spectrometer. Whereas organic mass spectrometers are the mass spectrometer which can be used for getting the molecular weight information or molecular structure information, also speciation studies. So this is the again broad way classification, the different ion source, the inorganic and organic mass spectrometer, which already I have covered. Now, so which one should use? Then, depending upon the type of sample and type of information required, one can use a different combination of the mass spectrometer. So if you have the solid samples, then the MALDI or SIMS is used, where you can directly convert the solid sample into the gaseous species. When you have the liquid samples, then you require the solvent ionization technique like APCI or ESIMS. And in gas phase, then electron impact source, which is again very old source. So now coming to the what is the electrospray ionization process. So I have just covered the historical development and different parts of the mass spectrometers. Now coming to the process of electrospray, this is classified the three steps. The first, as you can see the right side, the solution is allowed to pass through the capillary and with the help of the nitrogen as the nebulizer gas. At the same time, a potential of 3 to 4 kilovolt is applied in between. This is capillary and this one is known as in-plate offset. So these are acting as the electrode and counter electrode. So hence the potential of 3 to 4 volt will be applied. What will happen? The droplet, which is the polar, we are using the polar solvents, so it will regain the charge and therefore the charge droplets at the meniscus level will be attracted towards the opposite electrode. Suppose if there is the positive voltage, so what will happen? There will be the segregation of the ions. Negative ions will be moved towards the electrode, whereas positive ions, due to the similar charge, they will experience the repulsion and will be moved away from the droplet. So this droplets will be deformed like this one, distorted one, and that distortion is known as Taylor cone. So what happens? The Taylor cone, that means deformed droplets there. As we know, the droplets try to exist in the spherical shape, but since with the application of the potential, they are now deformed. At the same time, nitrogen is also used, heated nitrogen, as the curtain gas. So nitrogen is having a temperature of around 150 degrees Celsius, which is going in the counter direction to the droplets. So what it will do? It will evaporate the solvent molecules, because methanol or any organic solvent, they have the less boiling point, and therefore at that temperature they will evaporate the solvent. So now the ions which in the droplets were the solvated is now no longer remain as the solvated. Now it is acting like bare ion, and therefore bare ion will experience repulsion amongst each other. And when the Rayleigh limit of the charge is achieved, what will happen? Due to the repulsion between the same ion, there will be the Coulomb explosion. That means the droplets or charged ion is no longer remains together. They will come out as an individual species, and which will be again transfer. This process will be nothing but the transferring of the droplets into the gaseous species, and further the gaseous species will be extracted inside the mass spectrometer. So what is the major component of the ESIMS are the following. We have the electrospray emitter, which is nothing but the capillary, which acting as the spray of the solvent. Then also we have this whole process is taking place at the atmospheric region, where the three things are taking place: the evaporation of the solvent molecules, and therefore the shrinkage of the droplets. Then the next process is the production or transformation of the ions from the condensed phase to the gas phase, and followed by the extraction of the ion inside the vacuum where you have the mass analyzer. So if we see the characteristics of this process, it is nothing but the soft ionization technique, where we are using the potential of 3 to 6 kilovolt in between the two counter electrode, that means capillary and another end plate offset. And therefore at the tip of the electrode, when you apply the potential of 3 to 6 volt, the electric field is at the power 10 to 6 volt per meter. And in that field, what will happen? That in presence of the high temperature nitrogen carbon gas, the solvent is evaporated, and therefore the charge accumulation leads to the breakage of the highly charged droplets. And therefore the onset voltage, that means the voltage required to apply between the two electrodes, is nothing but depends upon the surface tension. Now, why surface tension? Because as you know, the surface tension is the force which is acting opposite to the Coulomb explosion, Coulomb repulsion. That means surface tension wants the ions to remain inside the droplets, whereas the Coulomb repulsion wants ions to get out from the droplets. And therefore, when the surface tension is overcome by the Coulomb repulsion, what will happen? There will be the transformation of the ion from the condensed phase to the gaseous phase. And therefore, the surface tension of the solvent is the important parameter for deciding the onset voltage. So if you compare water and methanol, water is having high surface tension. You require the high voltage to apply in between the two electrodes. Whereas methanol, when you use, you can transform the ions from the solvent to gaseous species with much less voltage. So the features of the ESIMS, as I said, that it can analyze the ions without any fragmentation. Therefore, the mass range is for starting with the 50 to 1 lakhs in by G value. And also the ESIMS can produce the multiple charge ion, which we will see in the today presentation. Now, another important thing is that, as I told, the depending upon the requirement, it led to, as said, the necessity is the mother of the invention, and therefore there was a requirement that can we directly analyze the separated liquid chromatographic fraction into the mass spectrometer. And of course, this ESIMS has capability to directly couple the very prominent liquid chromatographic separation technique, HPLC or capillary electrophoresis, to the mass spectrometer, where you can get the information about not only inorganic ions, polymers, peptides, proteins, and drugs, metabolites, etc. Now, what are the types of ion formed? It can be classified broadly into the two categories. One is positive ion. The positive ion is basically best suited for basic compound, where it can donate the electron pair for the either H plus, it can donate to the proton, or it can form the adducts with the sodium ion. So you can get the positive species. Also, the negative species, where if you have the ester compound like carboxylic group, the compound which contains the carboxylic group COOH, where the H plus can be ionized, and you will get the corresponding carboxylate anion, which can be ionized or determined in the mass spectrometer. But what is the challenges was there? As I told, the mass analyzer required the high vacuum, because then only you can have the high mean free path. Otherwise, as we know, at atmospheric pressure, the gaseous ions will collide with the atmospheric conditioned gaseous molecule, and it will lose not only energy but the charges also. Therefore, you need high vacuum. But the ionization is taking place at atmospheric pressure. So how to couple these two techniques? And therefore, the hyphenation is required. That also we will see. And since the ionization is taking place at atmospheric pressure, whereas the ion is transferred at the high vacuum, so there is the formation of the adiabatic. There is the process which is known as adiabatic expansion, which causes the cooling, decrease in the temperature, and that will lead to the formation of the cluster, because at lower temperature the different ions can come together, join together, and will form cluster. And therefore, you need to introduce the high temperature transfer tube, which is nothing but the capillary kept at the high temperature in the presence of the heated nitrogen gas. Now, this was the technique, because as told that we will see that there are a lot of background, and also that depend upon the solvent, there is instability depending upon the structure and type of analyte. There is the process signal suppression. Therefore, you can end up with the misinterpreting the data, and therefore this was very much famous cartoon where it was shown the electrospray is nothing but when the blind man sees the elephant, where depending upon the different parts, you can end up with the conclusion differently, which is not actual. And that is the very much essential thing required when one dealing with the ESIMS. Now we will see again the what is the mechanism of the droplet. What happens inside the droplets? So as we know, there are two types of species. One we call the hydrophobic species. One is known as hydrophilic species. And the difference is hydrophobic species will try, when you have the polar solvent, will try to remain on the surface. Whereas the hydrophilic species, if you have sodium as the cation, what it will do? It will try to remain inside the droplets of the polar molecule. So when the charging taking place, what happens? Due to the polar molecules, there is the dipolar moment will be there, and which will basically surround the ion molecules. And therefore, this is the arrangement of the ions inside the droplets, where the opposite end of the dipole of the solvent will stabilize the counter ion. And so what will happen? The charging is taking place at the surface, which is acquired by the solvent. Now, the advantage is when you have hydrophobic molecule, what will happen? The charging is taking place at the surface, and also the hydrophobic molecules will remain at the surface. So when the droplets disintegration, that means droplet fragmentation is taking place, then the molecule which is at the surface, they have propensity, they have probability to come out of the droplets faster compared to the species which is inside surrounded with the droplets. And therefore, when you analyze the bare ion like cesium ion and hydrophobic species like surfactant, this is dodecyl trimethyl ammonium compound. For same concentration of both the species, the intensities are quite different. The surface active compounds will be actively acquiring the charges at the surface, and also as we can see here, the progeny droplets, which is nothing but acquiring the more charges from the surface of the droplets and less mass from the bulk of the droplets, will be having more concentration of the surface active species like surfactants, and therefore when you have the same concentration of the ions and surface active species, you will end up with the higher intensity of the hydrophobic molecule, and therefore it requires the hydrophobic. If you have the hydrophobic species, they have the better sensitivity. Now what happens, why there is the formation of adducts? Now we know the NaCl, the well-known example. In solution, Na plus and Cl minus will be stabilized by the counter solvent. Solvation energy will be sufficient to separate these two counter ions. But what happens in the gas phase? Now gas phase, there is no longer solvent molecule which can stabilize these two counter ions and make separation. Therefore, when the compound is having like amines or amide, which has the lone pair of electrons, this sodium plus in the gaseous species, it will sit on the molecules, relax, and will be detected as the adduct species rather than the individual species. And therefore, there is the formation of the adduct species. Like whenever you analyze even neutral molecule, you will end up with the species as a M plus Na ion or M plus H ion. Now, the process which is responsible for the generation of charge droplets can be classified into two categories, basically. Now, how ions formation takes place, you see this one crowded train. It is nothing but the ion which is having the solvent molecule. Now, there are two different processes. If you have to kick out the heavyweight person, it is not possible to kick out when it is inside the train. But is it easier to kick out the lightweight person? And therefore, there are two types of mechanism for the formation of ions also. When you have the larger molecule, which is heavyweight, the formation is step by step. That means the solvent will be removed and a stage will come when the ion will be existing as a single ion. Whereas for the lighter molecule, what will happen? The repulsion itself is sufficient to kick out the smaller ion out of the solvent spheres. And therefore, this is known as ion evaporation because it is evaporating the ions. It is removing the ion from the droplets due to the repulsion. Whereas another is called charge residue model because the step-by-step removal of the solvent causing the high generation of the charge, and that is leading to the formation of the gaseous ion. So for the proteins, this kind of model is applicable, whereas for a smaller ion evaporation model is applicable. So already I have covered this part. Now I will come to the instrument which we have. The instrument is having the microtop Q-tube, which is the Drucker making instrument. Now what are the different parts of this? As I said, this is the ion chamber where the formation of ion taking place. Then this is called the hyphenation steps, where you are hyphenating or marrying between the species which exist at atmospheric pressure and the species which require the high vacuum. So then there is the mass analyzer where you can do the selection of the masses based on M by G, which is nothing but quadrupole. And there also collision cell where one can do the MSMS, that means fragmentation, allowed to undergo fragmentation of the ions for elucidation of the structure. And this fragmented ion is analyzed in time of flight. Another mass spectrometer, a mass analyzer, which analyzes based on the difference in the time of arrival of the ions. Now, suppose if you do not want to do fragmentation, then this whole compartment will act as the simply mass, which will act as the ion mass, it will accelerate the ions. So if you see the mass analyzer, we have the time of flight, which is nothing but if you give the same push for the different ions, then the ion which is lighter will travel faster compared to the heavier ion, and therefore the difference in the arrival time will lead to the calculation of the different masses. So then also we have, as I said, that MSMS experiment, which is known as tandem mass spectrometry. So what is happening in MSMS? You have the one mass analyzer where you can do separation, isolation of the interested M by D value, allow it to undergo fragmentation, and then fragmented ion can be separated by the second analyzer and followed by the detection. So this tandem is known as two types. One is called tandem in space. So this one is the tandem in space we have, because there are two analyzers at the different places. So it is known as tandem in space. Whereas the ion trap is another type of analyzer which is known as tandem in time, because there, depending on the different time, you can analyze the different masses. So as I said, that whatever the masses is formed, that is having difference in the energy. So you need to a ion transfer unit, which is nothing but ion funnel or skimmer. So ion will be transferred, and if we see the different vacuum, so the atmospheric pressure is for ion source, where the mass analyzer 10 to minus 7 millibar. Therefore, we need differential pumping for maintaining the different vacuum stages inside the spectrometer. And we have the microchannel plate, which is nothing but the semiconductor coated detector, which is basically ion will impinge, will generate the signal and will be detected. So as I said, the any analytical technique we require calibration, and therefore this also we have the sodium acetate, sodium format, which can be used for the calibration. And how we do the calibration? The interpretation of the spectrum can be done. Suppose if we have the chlorine, we know the chlorine having two isotopes. One is 35 Cl, most abundant, 75%, whereas 37 Cl is having 25 abundance. So when you have the Cl2 plus, then what will be the abundance of these different masses? It is nothing but the binomial expansion. So the ratio, the weightage can have like A plus B square, and the expansion is nothing but the weightage of the individual isotopes. So it is shown here that suppose 3:1, if this is the dimeric species, the spectrum will look like 9:6:1 of the different mass combination of 35 and 37. Now, so whenever we have the different species, we do that. First of all, the calculated mass we calculate, and from the experimentally observed mass, we match the pattern. Also, depending upon the species, spacing between the two isotopic masses, we can also find out what is the charge. Like suppose if it is the monovalent, then the spacing will be 1 unit, and we will see if it is the multiple valent, the spacing will be divided by that much charges. And I told that this is the best thing, hyphenation of the technique with the liquid chromatography. So I will just directly come to the application now. The application which I am going to present basically, which we have done, the electrospray ionization source was used for the study of the metallic and the speciation. As you know that lanthanide and actinides, both the species elements are most reactive in the periodic table, chemically reactive in the periodic table also. So it was of interest that what are the different species formed when we have even bare solvent and ligand also. So this is the spectrum. When you have the uranyl ion, as we know, the uranyl exists as UO2 2 plus in the aqueous solution. That means uranium exists in +6 oxidation state, and similar to the molybdenyl ion, vanadidyl ion, it is also existing as the uranyl UO2 2 plus. When it is subjected inside the mass spectrometer in ESIMS, what happens? Now charges is more on the bare ion. So what will happen? Under that condition, uranyl will no longer exist as UO2 2 plus, rather it will undergo reduction and will form UO2 single plus. that will be detected at the 270 MBG value. But as I told that there is solvent molecule present. So what will happen? Uranyl, it is hard acid, has propensity ahead based on HSLB principle. It can combine with the hard bases like methanol and water will form the different species like uranyl methoxide ion. Now, this uranyl 2 plus ion is stabilized by the methoxide ion. Therefore, this species will be having a single charge. But the interesting thing, if you see this spectrum, this comes to 301 its mass, 0.15. So one can again misinterpret this as a uranyl methoxide species. However, when we use the electrolyte like sodium chlorate or perchloric acid, because these two electrolytes has non-complexing tendency and therefore it is used in metal ligand solution chemistry studies. So we found again different pattern of the same species. Like you can clearly see the calculated mass and observed mass is matching, and the pattern is also is different than the previous one. That means now it is uranyl 1 methoxide, or uranyl hydroxide. These are the different species. Therefore, one has to be very careful for analyzing the mass spectrum, because if you calculate the different combination, you may end up with these all species, no doubt, because you can see the different fragmentation or different combination, but which is not the actual species. Now, why this is happening? Because in electrospray, that convection of the solvent is very important. So in presence of electrolyte, it improves the conduction of the solvent, and therefore it also gives a better chance for analyte ion to convert from the condensed phase to the gaseous phase, and therefore we have the very neat spectrum. And then the another work was that how this solution phase is represented in the gaseous phase, because there is the probability of different combination reaction during the transition from these two processes. So the famous ligand which was used is alpha hydroxy isobutyric acid containing hydroxyl group as well as carboxyl group also. And this is also mandelic acid having the same, if you see the binding moiety is the same carboxylic and hydroxyl group. And the stability constant value are different for the ML1, ML2, ML3 species. Now what it means, if you have the higher concentration of the ligand, then with the time you will see the higher percentage of ML3 species over the ML1 and ML2. So this is the different possible species in positive and negative mode. Now another better thing about this is that the same species can be detected in the negative mode also and positive mode. That means you can remove the artifacts or probability which can happen during the gas phase. So more confidence about the formation of the species by analyzing the same species in the two modes. But what we have seen that in negative ion mode, we found the ML3, because it is also having the higher stability constant, ML3 species were more dominating over the another. However, in positive ion mode, we found the ML3 is the less dominating over the ML2 and ML1. But depending on the stability constant value, it should have been also the highest dominant species. So what was the reason? Initially, we thought that since carboxyl group is having the ability to ionize at the pH 4 and 5, so it is inherent easiness in the formation of negative species in the negative ion mode compared to the positive species. But it is not the case. It was the experimental parameter, like the different ion transmission parameter which was responsible for the difference in the spectrum. What it was causing, like collision cell energy, it was causing more fragmentation to the Ml3 species, and therefore in positive ion mode, even though we have the higher metal to ligand stoichiometry, but Ml2 was most dominating. And therefore, we systematically optimized the experimental parameter, and then we got the ligand to metal representation in gas phase also similar to the solvent phase. Similarly, experiments were done with the mandelic acid. Now, another things we wanted to do, that if you do see the separation of thorium and uranium, both are hard acid, but in presence of hydroxycarboxylic acid, they have a different elution pattern. That means thorium elutes prior to the uranium. So what was the reason of that? And that also we have corroborated with the help of ESIMS, where we could able to see that uranyl hibide and uranyl mandelic acid species are similar, whereas thorium are having difference in the different species. Then this work is for the platinum group of element with the benzoyl thiourea. Now, interesting thing I would like to show that we have used the 3 different thiourea moiety. You can see the thiourea, which is the monodentate. Benzoyl thiourea can be monodentate as well as bidentate, and N-diethyl benzoyl thiourea, it is exclusively bidentate. So if we see the different species, when you have the thiourea, then the higher valent or higher stoichiometric like Ml3 is the most dominant species. In case of benzoyl thiourea, as I said, that it can form the monodentate as well as bidentate complexes. So Ml3 was dominating, but Ml2 also considerably very high. Whereas in case of diethyl benzoyl thiourea, exclusively Ml2 species form, and therefore it shows that whatever the solution binding chemistry is also representing in the gas phase. Not only that, we also studied the MSMS, that means fragmentation of different species, and we found that when you have the benzoyl thiourea and diethyl, since it is the exclusively bidentate mode, which is more stable compared to other species, and therefore the daughter by parents ratio is lesser for the benzoyl thiourea. Now, this is another interesting example we have calculated. You have the macrocyclic ligand, macromolecules like carbobutyl 5. They are like may have the moiety which inside, so uranyl can sit inside. Not only that, uranyl can also complex with the sideways also. So we could able to see when uranyl sitting inside the moiety, we have the uranyl doubly charged species. You can see the spacing between 0.5 AMU shows the doubly charged. And when uranyl is the sideway binding, we have the monodentate species. That means it is uranyl is undergoing reduction or combining with the hydroxide or methoxide which is present in the solvent. Then I will just go to the another interesting example of metal equilibrium study where I have carried out the lanthanide. As you know, lanthanum to lutetium, the ionic potential increases because the charges radius is decreasing from lanthanum to lutetium. So when given ligand, what will happen? For given ligand to metal ratio, lutetium will be having more tendency to form the metal ligand species compared to lanthanum, and that's what we have seen. So for 1:1 ratio, the bare metal, that means uncomplex metal, was lesser for lutetium compared to lanthanum, and that we have studied by using the mass spectrometer. Not only that, we also studied the fragmentation and different fragmentation product we have analyzed. Now, this is another reactive red dye. As you know that nowadays the degradation of the red dye is very important because of it is being discharged in the water stream, and therefore in BRC also the radiation based the degradation is being studied. So there was the requirement that can be analyzed the degradation products. Yes, we have done, and you can see the 5-unit charge here of the species. Like the spacing between the two different isotopic pattern is 0.2 AMU. This shows that as told that it is having -5 unit of negative charge, and that successfully only ESIMS can do. Now, these are the example I have taken from the literature where the different arsenic species can be directly analyzed by in ESIMS. And now coming to the another application of the natural products, it is again from the literature, then this ESIMS can be used for analyzing the different fragmented product for the elucidation of the structure of the natural product. Not only that, it is also used in the drug discovery, because where you can find out how gene is complexing with the protein, and the different binding species can be calculated directly by using ESIMS. Not only that, now COVID is going on, so this is also has been used for analyzing the viruses which is deactivated, and then it has been digested using the trypsin, and then by using LCMS, the sequencing of that viruses has been done by using ESIMS, and also MALDI is another complementary technique. So with this is my slide where the information is given. If you want to determine, for especially for the PhD scholars, structural information, then what are the different techniques you can use, like NMR, metal ligand interaction, GANs, then the XRD, time real laser fluorescence. If you want to get information about molecular information, so then of course mass spectrometers, and there are the software analysis technique. Want to know isotopic information, then you have to use the elemental analysis technique like ICP-MS, thermal analysis mass spectrometer. And if you want to do the imaging, spatial imaging, molecular imaging, then the techniques are like SIMS, MALDI, and elemental imaging, then laser-based technique as is being used for the analysis purposes. So again, this is a comparison between the different mass analyzers, because paucity of the time I could not cover. So there are different mass analyzers. So if you see the high mass range time of flight offers, whereas the resolution is being offered by the high ion cyclotron resonance, where highest dynamic range is by using magnetic sector instrument. And therefore, now coming to the end, I would like to acknowledge my group director, Dr. Pujari from Radio Chemistry and ISO group for his support, and Dr. Eskander, head FCD. Also, I would like to thank Dr. PG Jason, who is my mentor also, and currently heading the mass spectrometry section. My lab colleague Vijay Tolmore, who is like my colleague, which is always there for any experiment which I have shown here, and all the staffs of my section, also the electronic equipment services section of RCD for supporting. I would be fair if I won't acknowledge my previous guide, Dr. S.K. Agarwal, former head of CD, and Dr. Dian Mujib, former head of mass spectrometry section, for their support. And they have also bring me in this field. These are some publications, references from the literature, and these are my publication which has been generated throughout the experiments. And this is my last slide. As today we are discussing today flying elephant, this is the sad day today because we lost the flying man, flying sick. And so my condolences to him, his rest in peace, his soul may rest in peace. And also we shall overcome the pandemic with the great efforts. Thank you all for your attention. Thank you everyone.
Thank you, sir, for your nice presentation. Over to Shreya.
Yes. Thank you so much, sir. Thank you for giving such in-depth knowledge through such an insightful talk about mass spectrometric analysis. The relevant animations that were used to explain the talk made all the information stimulating and extremely interesting. The start of the talk with the flying elephant concept itself piqued interest and curiosity in our minds, and it actually forced us to think whether the elephant can fly. So, yeah, I am sure this informative talk would benefit all of us. Now, if you have any questions, you can put them in the chat box. We will move to the next space of question and answers. I will read the questions from the chat box, and Dr. Pranav Kumar, you can answer those. So yeah, the first question being how to avoid enhance. Is someone speaking? Yeah, sorry. So how to avoid enhance the ionization in ESI, whether tuning voltage could help or any salt buffer has the role?
Yes, this has the salt both is helpful for analyzing the species. Like if you use the less voltages between the electrode and in-plate offset counter electrode, then what will happen? You can have the more softer condition for transferring of ions from the solvent to the gaseous phases. Also, salt, as told that salt is required for maintaining the conductivity of the solvent, and therefore the salts also is required when you have the neutral species like amides or amines. Then it is again required for the formation of adducts, and that can give the better sensitivity in ESIMS. So both is helpful, but at the same time, if you use the very soft condition, you may end up with the aggregation of the different clusters ions also, which also can give the misinformation about your species which is present in the solution, especially when you're dealing with the very reactive elements like actinide or lanthanide. So those tuning is very important. Therefore, always when one dealing with the metal ligand equilibrium, one should always cross check with the solution phase instruments like either the well-known potentiometric experiment or any other kind of species and techniques which should be used in order to verify whether you are getting the species which is well versed with the reported or analyzed differently technique or not.
Okay, thank you, sir. So we move ahead to the next question. So what exactly is tandem mass spectroscopy, spectrometry?
Tandem mass spectrometer is nothing but you are using two mass spectrometer. So what you are using, you are exploiting the capability of the individual one. Like as I told, the quadrupole ion is very fast in scanning, whereas it has again limitation of the mass ranges. Therefore, if we couple with the another mass like time of flight, then both the capability of fast scanning and time of flight can practically analyze the all masses. It has no limitation. So this capability can be used for getting the better information. Now tandem, I was told that it can be in the space because here the two masses are situated or located at the different places. Whereas in term, it can be in the time also. So same mass can be used for that tandem way for the different ions depending upon the difference in the time.
Okay, thank you, sir. So our next question is from Dheeraj, sir. So could you please explain how combining gas chromatography and mass spectroscopy can be helpful in separation of components, its working and principles?
So gas chromatography was well known because what was the principle of gas chromatography? Any chromatography technique. The principle is the differential migration. The different species will be having different interaction towards the stationary phase and mobile phase. Therefore, they will be having difference in the migration. So that was the well-known principle of the chromatography. Now, what was the difficulty of the GCMS? As you know, the GC gas chromatography, you have to convert and light of interest into the gaseous phase. Now, what will happen? There are many thermally labile species. When you heat it, what is the way of conversion of gaseous species? You thermally heat it. So what will happen if thermally labile species is that it will undergo degradation, decomposition, and therefore all species is not amenable for the analysis in the gas chromatography and mass spectrometer, because that time the electron impact was used. So whatever the species which can be converted into gaseous form, they can be analyzed by impacting with electron. However, as told that the macromolecules and proteins, they cannot be converted in the gaseous form. So then it was highly required the technique which can be used for the direct conversion of solution to the gas phase without decomposing or degrading the analyte. And that was the electrospray ionization mass spectrometer coupled with the LCMS. So LC is again having the better, if you compare GC and LC is having better solution chemistry, and therefore it offers the better separation compared to GC. GC is having high diffusion, so it is faster, but LC is having better solubility, therefore it is offer better separation. And therefore the LC combination with the SIMS, that mass spectrometer has offer all the, if you see protein separation or biomolecules, that has given a new dimension. So earlier it was used as the physicist. Now in the mid of the 1950, chemists started using, and now this technique is mostly dominating by the biologist. Now it is because of the advent of this LCMS. Now mostly biologists are using more compared to any other specialist you can see. Hope it has answered.
So Dheeraj, so you can type it in the chat box. Thank you, sir. So our next question is by Dinesh Reddy, sir. So he asks for an explanation about GCMS and EIS, which is the best technique and why?
See, there is, as I told, there is no best technique. It is depending upon what kind of information you need. Like if someone wants isotopic composition, they cannot use ESIMS. So it is for them, ESIMS is not the best technique. One has to see the elemental technique. Similarly, if someone wants to get the technique which is the molecular information, then the elemental techniques are not of much use for them. Therefore, both is having their applicability as on today also. It is not that this CMS is outdated. It is again being used for the study of the different species. So depending upon type of uses, as I have given the last slide, that if you want the different information, you can use the different combination of the technique. That is the take home message from this presentation. It is not the best and worst.
Okay. So there are a few compliments in the chat box as well for you, sir. So our next question is by Rajiv, sir, that GCMS or LCMS, which method is more suitable for ionization by electron spray?
Of course, LCMS. Electrospray deals with the transformation of the solution species which is in the solution to the gaseous form. When you have the GC, then I told that it is GCMS with the electron impact ionization. So that is the difference. Many people say electron spray. It is not the electron spray. Electron impact source is different than the electrospray source. Electron impact means where the electron gun of the energy 17 electron volt will be used, which will cause the ionization of the species and also fragmentation of the species. So that's why it is called electron impact, because electron is impacting the solution, analyte of interest. Whereas electrospray means we are analyzing with the spraying the solvent. So there are two broad categories. One is called spray ionization. Another is called desorption ionization. So mainly those techniques are called desorption ionization, where you are basically dissolving the solid into the gaseous by using laser, as the Ganeshan sir is there. So laser is one of the technique which is used for the desorption purposes, from directly conversion for solid to the gaseous. So those techniques are known as desorption ionization. Whereas when you convert the solution to the gas, this kind of technique is known as solvent ionization technique or spray ionization technique. So this is the two differences between electron impact and electrospray, and also MALDI, which is laser-based technique.
Yeah. So our next question is by Rakesh Ranjan sir. How can we minimize the adduct formation or to avoid crow's peaks?
So the first thing how to avoid adducts is, one thing, you have to use the declustering processes. So declustering process is nothing but, still you able to view my slides?
Yes, sir.
Okay. So I will give in the. Just a minute, please. So this is the declustering process here taking place. Means you have the species which is aggregates like clustered. So what you do, you use a high temperature for effectively removal of the adducts, or also you use in-source collision in this dissociation. This is also called in-source. That means when ion is entering inside the vacuum, you use the high potential difference. So what will happen? The higher kinetic energy will lead to the declustering of the analyte. So these are the two stages where you can use the declustering of the species, and you can minimize the adduct formation. So by applying suitable potential or voltage at in-source collision in energy dissociation, and also by using the suitable temperature, and also by suitable voltage difference at the ionization. So these two places one can use for the minimizing the clustering process. Hope it has answered or anything regarding that.
So Rakesh, so you can put it in the chat box. Yeah. He has. So our next question is by Vaishali ma'am. So please explain metal ligand equilibrium.
So again, I will use the presentation. So this is metal ligand equilibrium. Now what is happening, that as we know, a metal and ligand, now they will form the different stoichiometric composition. Now it is not that Ml3 will form directly. The process is, it will form like Ml1, Ml2, and then Ml3. So this species which is in equilibrium with the metal or ligand has to be studied. So what is the way of studying metal equilibrium? Is nothing but the best way the finding is the stability constant, which will give the idea about that what is the dominance of, or which is the dominant species. So this is one of the good technique, not good technique, but especially for the ligand which is not having the ionizable proton, it can be used by this technique. How? That, as you know, that equilibrium constant is nothing but concentration of product by concentration of the ligand, reactant. So the concentration of product can be determined by finding the concentration of the individual species. And now individual species, how one can find? What is the fraction of that species? That means you have ML1, ML2, and ML3. So what is the fraction of ML1? That can be directly correlated with the intensity. So intensity of ML1 divided by total intensity will give the fraction of the ML1. So from there we can find out what is the ML1 and the uncomplex species of metal and uncomplex species ligand. By computing this value, one can study the stability constant, and which will give the idea about the metal ligand equilibrium, that how the different species are behaving in the presence of the given condition.
Thank you so much, sir, for such explanatory answers. I believe the question and answer.
Yeah, I have a comment. I am Dr. Chandrachudan here.
Yes,
Am I audible? Am I audible?
yes, sir.
So I would like to place on record the extreme appreciation for the excellent clarity of your expression, both during the presentation and answering all the questions. It was an excellent professorial talk, and we highly appreciate your webinar. Thank you, Dr. Pranav Kumar.
So thank you, sir. Actually, I also would like to thank Chandrachudan sir because and Saran sir, especially Chandrachudan sir, because I was a little nervous before making presentation, but it was the Chandrachudan sir. He told that he is also from the training school and 13 batch, so he is 36 years senior to me. So it was like a senior is guiding to the junior. So in that spirit, it relieved me a lot, and that is because of the sir, your special affection towards your junior, I can say. And thank you, Adya madam, also because your persuasion and your suggestion has helped me to make the presentation. Thank you, Shansan, and all the organizing teams. Thanks a lot for giving me this opportunity. Thank you all.
Thank you, sir. So, as you can see, the chat box is filled with compliments for you, sir. And hence, we conclude with the round of questions. And now I would request Dr. Kanungo, sir, Vice Chairman ISAS Nagpur chapter, to cite the Certificate of Excellence to today's speaker.
Thank you, ma'am. Good evening to all. Really, Dr. Pranab Kumar has given an excellent...
Sir, sorry to interrupt.
Hello.
Indrani ma'am, are you there? Indrani, please present the certificate. Indrani?
Yes, sir. I'm just doing that.
Please present. Okay, sir. Dilip, sir, you can continue.
Yeah. Good evening to all. Dr. Pranab Kumar, has given an excellent and lucid presentation with his dedicated and research in the field. He has delivered an insightful talk on electrospray, ionization, mass spectrometry, instrumentation, and applications on today, it is on June 2021, during which he shared his immense insight, great expertise, and enriched knowledge about basics of very useful analytical tool of electrospray ionization mass spectrometry, recent technological advancements in the instrumentation and its usefulness in diversified fields of sciences and technology. The talk in this national webinar synergized immensely with the objective of ISAS in promoting excellence and relevance. So the Indian Society of Analytical Scientists headquarters and ISAS Nagpur chapter, along with chemistry department, Sri Ramdeobaba College of Engineering and Management, Nagpur, in recognition of the outstanding research, is happy to confer this certificate of excellence on Dr. Pranab Kumar. So, a senior scientist, Fuel Chemistry Division, BRC, Mumbai. I would request honorable guest, Dr. A.S. Ganesan, sir, Professor and Department of Medical Physics and Director, Health Center, Anna University, to present virtually the certificate of excellence to Dr. Pranab Kumar for his excellent and talk today evening. Dr. Ganesan, sir, please.
I'm really happy to present this certificate to the scientist. He is not only a scientist by the way of his presentation, he has proved that he is a good professor also. No, his present is very nice, sir. Like a teacher, you know, you explained everything from the concept to the application, sir. I'm happy and honored. No, by the way of giving this presentation to you, sir. This honor,
Thank you, sir.
the certificate
Thank
is
you.
expressed to you, sir. Thank you, thank you,
Thank you.
thank you, sir.
Okay, thank you, sir.
Thank you, sir.
So, yes, with the Certificate of Excellence virtually handed over to our speaker, I now request Dr. Indrani Das Sharma, Associate Professor, Julelal Institute of Technology, Nagpur, to propose the vote of thanks.
Thank you, Shreya ma'am. It is my honor and privilege to propose the formal vote of thanks. I'm thankful to Chandrachudan sir, President ISAS, Dr. Raghav Saran sir, Vice President ISAS Nagpur chapter. I'm also thankful to Dr. Avinash Bharati sir, Chairman ISAS Nagpur chapter. Today's chief guest, Dr. S. Ganeshan, for sparing his valuable time and to guide us in this webinar. Many thanks are due to Dr. Pranav Kumar, Senior Scientist of Bhabha Atomic Research Center, for a wonderful presentation of mass spectrometry. His lecture was truly an insight for us, and it was a very well explained lecture. I'm thankful to all the ISAS members of Nagpur chapter, various other chapters of the country, as well as headquarters of ISAS, and the webinar committee for making this webinar a grand success. And finally, the thanks are due to the delegates, without whom this webinar would not have been a success. Thank you for giving me opportunity to propose the formal vote of thanks. Thank you one, thank you all. Over to you, Shreya ma'am.
Thank you, ma'am. So, with this, we conclude today's webinar. Thank you, everyone, for joining in and cooperating. Thank you.
Thank you, everyone. Thank you, everyone. Thank you, Dr. Ganeshan, for speaking. It was very nice.
I
Thanks a lot,
thank
Dr. I thanks Dr. Ganeshan. Dr.
Yeah.
Pranav. Nice talk.
We are,
Thank you.
yeah,
Thank you.
yeah,
you.
Thank